Hello everyone, my name is Tim Holm and I am a co-founder and CTO at Nitric. In today's presentation, I'll be discussing Nitric's approach to engineering a multi-cloud platform and how Pulumi has enabled us to do this. Additionally, I'll talk about Nitric's unique approach to self-service infrastructure and explore how leveraging it can significantly boost developer productivity and elevate their overall experience. Let's dive in. I assume that since you're attending this presentation, you're already familiar with the advantages of multi-cloud, so I won't delve into that aspect today. Instead, I'll briefly touch upon the key enablers of multi-cloud strategies. The type of multi-cloud strategy I'll primarily focus on is the cloud-agnostic approach, where maintaining consistency across various cloud platforms is crucial to prevent vendor lock-in and ensure redundancy. There are two main approaches to achieve this. The first, and perhaps more common approach, is employing Kubernetes. This involves using cloud vendor-agnostic technologies that can be deployed across multiple cloud platforms, resulting in consistent clustered environments. The second approach, which will be the focus of this presentation, is an abstraction or facade method. This method takes cloud-native concepts and resources and abstracts them in a way that allows interaction with multiple services through a single API. Nitric makes use of this approach, allowing it to leverage managed services and solutions from multiple cloud providers, such as AWS Lambda and Google Cloud Run, while still allowing developers to maintain a single codebase for both. Creating an abstract platform has its own set of obstacles. Firstly, we have to take into account the unique features and constraints of each platform, which can make smooth interoperability challenging. Moreover, integrating components can become complicated and may lead to performance issues. Lastly, ensuring consistency across platforms is pretty demanding. In Nitric's own journey implementing our framework, there have definitely been many design challenges we've had to overcome to mitigate some of the downsides of platform abstraction. However, one thing we've found at Nitric is that many of the staples of the cloud, such as buckets, topics, queues, and API gateways, their implementations differ only in semantics and are effectively functionally equivalent. Despite the challenges involved in designing and building platform abstractions, the advantages of platform abstraction are worth the effort. It offers increased flexibility and scalability, facilitating the adoption of new technologies with ease. Furthermore, abstraction enables multi-cloud strategies, broadening the range of options for organizations. Importantly, it helps reduce vendor dependency and can promote better cost management by allowing you to switch providers more easily, as well as allowing you to deploy using services best suited to your workloads. By using the decoupling that abstraction gives us to our advantage, we can connect new concepts directly with our application in a way that doesn't lock it into a certain cloud implementation. Instead, we can let our apps tell us what they need using cloud-native concepts that can work consistently with different cloud providers. For example, imagine a hypothetical SDK designed to make this level of abstraction easy. This SDK could give us a standard way of working with different cloud services, allowing developers to write code that doesn't care about what cloud provider is being used. It doesn't even have to be an SDK. This idea can be put into practice using annotations, metadata related to an app, or even whole new languages. Once we figure out these more abstract requirements, we can hook them up with our infrastructure automation processes. This would let us automatically set up resources and services our app needs without having to do it all by hand. Basically, we'd be plugging our apps into our infrastructure automation APIs, making it easier and smoother to deploy and manage apps on the cloud. So what happens if we do this? This happens. These are technologies that exist today that in some way embody this principle. This concept is known by a few names already, with infrastructure as code and self-provisioning runtimes being the most prominent ones. The central idea is that by creating platforms and frameworks from which infrastructure can be derived, we can streamline the entire development process. This approach eliminates the need to develop and maintain application and infrastructure stacks separately, ultimately enhancing efficiency and reducing the likelihood of errors. Each of these techs features its own unique implementation. Many of them are also powered by Pulumi under the hood. I also wanted to mention the Pulumi Cloud Framework here. While not actively being worked on, I feel it has provided inspiration to other players in this space and exemplifies the simplicity that can be brought to cloud development when taking this approach. The concepts introduced by these solutions are incredibly powerful tools for developers and organizations alike. By leveraging infrastructure from code, companies can accelerate their development cycles, improve resource allocation, and enhance overall agility. We can see in this example using Nitric how this kind of approach to cloud development changes developer perspective. Utilizing a provided SDK, developers can seamlessly incorporate cloud-native concepts directly into their application code, effectively making their applications cloud-aware. The infrastructure showcase in this example represents a simplified summary of what would be deployed if you were using Nitric's AWS provider. It's important to note that this isn't an exhaustive list of requirements, but it still surpasses the number of lines of code in this example. This example highlights the complexity of deploying even a trivial application to the cloud, where 7 lines of code result in the deployment of more than 8 actual cloud resources. We can also see here how this example makes security concerns such as principle of least privilege first-class citizens, by allowing developers to declare how their applications intend to interact with cloud resources at runtime. By bringing self-service to this level, we can significantly reduce cognitive load and dramatically improve productivity. This approach enables developers to concentrate solely on the logic and value of their applications, shifting the focus from catering to the cloud's needs to the cloud catering to your applications. By simplifying the process and reducing cognitive load, developers can spend more time focusing on delivering value and functionality. Let's finally dive into the exciting part, the demo. I'll walk through the development lifecycle of a Nitric application from local development and testing to cloud deployment. During deployment, we'll deploy the same app to 2 different clouds using their native managed services. Then we'll use a small Pulumi program to set up load balancing between the applications with Cloudflare, making it a truly multi-cloud application. For the Nitric deployments, we'll be using the out-of-the-box AWS and GCP provider plugins. These providers are focused primarily on getting developers started quickly with developing Nitric applications and getting their code into the cloud as quickly and correctly as possible. By the end of this demo, you'll get a glimpse of the Nitric application development process and also see how to integrate out-of-the-box Nitric providers with your own Pulumi programs. Alright, straight into the code. So the core of any Nitric application is its project file or nitric.yaml file. And if we take a look here, it contains 2 key components, the name of the project, as well as a list of handlers that compose the code of the project. These handlers are what the Nitric CLI will use to both run the application locally, build it for final deployment, as well as querying the application for any cloud resources it needs during its deployment. So if we take a look at the functions directory here, we can see a single function called game.ts. At the very top of that function, we see the first use of the Nitric SDKs, where we're importing an API function that we can use to declare API gateways. Now, this isn't the only thing we can do with the Nitric SDK. It contains capability for many of the staple resources you use in the cloud to deploy distributed applications, such as topics, queues, and buckets. But for now, for the sake of simplicity, we'll just set up an API gateway. So here we're declaring a single main API and connecting it to some middleware we'll be using to demonstrate the multi-cloud capability later in the demo. And to that main API, we're attaching a few routes. We have a single route here called room, an index route that's serving a simple HTML page, and another route called sprites that'll be serving some assets for a HTML page. So what does this application do? Let's see. So we can do local development in Nitric quite simply. We have a start command as part of our Nitric CLI that will emulate a local cloud environment. And in our TypeScript template and JavaScript template, we have a simple command you can use in the package.json to get that running with your actual functions, all in one seamless command. So I'll run that here using yarn dev. And in the left panel, you'll see the start of the actual, the Nitric start command in the CLI. And on the right panel, we'll see the console of our running application. Now, out of the box, we do support some hot reload capability as well. So if I were to make some changes to this code and just add, say, a quick console.log, say, starting application, and save that, we'll see on the right-hand side that it restarts, and on the left-hand side, the API gets re-registered. Now, that API we're seeing on the left-hand side by the name of main, here we can see, and it's now accessible at localhost 4001. So if we get that address and just punch that into our browser, we should be able to see what this application is doing. So I'll just run that there, and we can see it's a game. The Legend of Pulumi, Pulumi Adventure. And if I just press space here, it'll open up the network so you can see what's going on there and reload. We can see we're serving the assets from that API, but we're also serving, definitely not a game developer, but I thought it'd be a fun demo that ties into the theme. We can see here we're getting a bunch of calls to that room method we saw, and what this is doing is actually generating random rooms for a never-ending dungeon. And you can see it changes with every single room. And I will point out at the bottom there, we've got that powered by unknown. I'll be using that later to demonstrate the load balancing across clouds when we finally make this a highly available multi-cloud application. So, without delaying any further, let's close the local dev for now and get it deployed into the cloud. So deploy to the cloud with Nitric is basically as easy as hosting your application locally. The main thing we need is a stack file. So I'll open up one of our stack files here, which we'll be using to deploy to AWS. Now, a stack file contains two required components, the name of the stack and the provider plugin we'll be using to deploy that stack. And then after that, you can provide any other options you like. And these options are generally specific to the provider you'll be using. In this case, we only have one required additional option for the AWS provider, which is the region we'll be deploying to. Every other configuration option for that provider is completely optional. So all we need to do to get that deployed is to run nitric up. And I'll be adding a verbose flag here as well, just to show you what's going on behind the scenes. It will make the output a little noisier, but hopefully if you're familiar with Pulumi output on the CLI, you'll see a few familiar resources pop up as I'm making this deployment happen. So I'll just run that. I'll select prod AWS. Now, for the sake of time, I have pre-deployed this, but you should see that the Delta check as part of this deployment, there shouldn't be any or minimal changes as part of this deployment. So hopefully you can see some of the Pulumi resources pop up there, and we can see 16 unchanged resources for this deployment. As part of the output, we've outputted the API endpoint that we'll be using. So this should hopefully behave exactly the same as our local deployment. And we can see that it does, with one exception. Down the bottom, we can see that it's claiming that room was generated or powered by AWS. So we can see in the console here. So just a quick test of this application just to make sure everything's working okay. Seems to behave exactly the same as the local development. So let's jump on to getting this into GCP. Exactly the same command. I'll just run nitric up with that verbose flag again and select the GCP stack. Now this might take a little bit longer than the AWS stack, but there should be minimal changes. So we can just watch all that output go by. Excellent. So we can see that there was a minor change to the Cloud Run service template there. The same thing as before, we get that endpoint output. I'll just copy that into the browser and we can test GCP just to make sure that's working exactly the same as well. And down the bottom, we can note that it's saying powered by GCP. So that looks pretty good to me so far. So what we've done is we've managed to deploy from one code base to two different clouds, entirely different runtimes, and the behavior is exactly the same between both of those. So now what we'll do is we're going to run a small Pulumi program that I've written here, and we're going to load balance these two to make it highly available and truly multi-cloud. So in this info directory, I've got a small Pulumi program I've written using the automation API. What it's going to do is it's going to extract information from the two stacks I deployed earlier, extract the domain names of each of those gateways, and add them to origin pools for Cloudflare for load balancing. And at the end, I should get an API output and then be able to access that load balance API. So for convenience, I've just written a quick script here, yarn deploy LB. That should deploy our load balancer to Cloudflare. This shouldn't take too long. And once that's deployed, I'll just grab that endpoint there, copy that into our browser, And if we watch that network tab there, we should see even the assets that make up the game be load balanced across these clouds. So if I flick through them really quickly, you'll notice this quick cloud line here. I just click through those. So first few with GCP, then we've got AWS, GCP, AWS, and so on. Now, the main thing we want to look out for is that continued room call that's generating these random rooms for the dungeon. There should be a powered by statement in each room that tells you which cloud generated the room. Now, the steering policy I've got for this is set to random, but you can see almost immediately I went into the next room and now I have a room powered by GCP. And as we move on to the dungeon, you'll see it switch over. AWS, AWS again, and so on. And that's it. So now what we've done, single code base, we've deployed to 2 completely different clouds using exactly the same code, gotten their APIs, load balanced them with Cloudflare, and now we have a highly available, truly multi-cloud application that's a really fun game. If you'd like to try out this demo for yourself, or just check it out and have a poke around the code, you can find it at this repo. If you have any issues getting it up and running, feel free to drop into the Nitric Discord for some help. So let's take a peek under the hood of what was going on in the demo. An application built with the Nitric SDKs communicates with the Nitric CLI, allowing the application's infrastructure requirements to be compiled into a set of cloud resources, which lays the groundwork for the deployment process. These requirements are then passed on to what we call a provider. Nitric providers interpret the application's requests and convert them into concrete cloud resources required for the application to run. Providers act as full cloud implementations, controlling all non-functional concerns, such as the underlying services, memory, CPU, resource count limits, as well as security and compliance requirements. Nitric's default providers are powered by Pulumi, specifically the automation API. This API allows us to put our Pulumi programs behind a plugin interface for the Nitric CLI. Out-of-the-box support for deploying applications to AWS, GCP, and Azure is available, and building providers this way makes it easy to share logic and libraries between deploy time and runtime components, creating a cohesive development experience when using Nitric as an implementation. Using Pulumi's automation API brings us several advantages. For one, it greatly simplifies the packaging and distribution of provider plugins, allowing them to be shipped as single binaries. This makes it easier for these binaries to be fetched on demand, not unlike Pulumi's own resource providers. I'd also like to emphasize the flexibility of Nitric providers. It's entirely possible to extend the capabilities of an existing provider, or even write your own from scratch. This ensures that you can tailor Nitric's platform to suit your specific needs, connecting code directly to your deployment engine. I'd like to take this opportunity to encourage everyone to explore this concept for themselves. And if you're feeling particularly adventurous, give Nitric a try while you're at it. I'd also be stoked if you took the time to browse through our docs and GitHub repo, where you'll find all the resources and tools necessary to help you get started. If our work resonates with you, we'd greatly appreciate it if you could support us by giving our project a star on GitHub. Your feedback means a lot to us and helps us reach a wider audience. On the other hand, if you believe there's room for improvement, or you have any suggestions on how we could enhance our work, share your thoughts with us. We're always eager to learn and refine our efforts, and genuine input and feedback makes all the difference in our ongoing quest to make our framework as awesome as possible. Once again, I'd like to thank you all for your time and interest. Thanks for joining, and a huge thanks to Pulumi for giving me the chance to share these ideas. If anyone has any questions or comments, feel free to reach out to me or join the Nitric Discord. I'm always happy to chat. Or visit our virtual booth. Our team would be more than happy to answer any questions you might have. That's all I have for now. Thanks everyone, and I'll see you later.